Here are the trig questions from the review. So I'm going to be using the SOHCAHTOA rules. Sine, of course, is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember, if they ask you to find a sine, cosine, or tangent, they want a fraction. So I'm going to go fill in the missing side on this triangle, this little 5, 12, 13 triangle. So it's asking me for cosine of theta, so you go to the angle. Cosine is adjacent over hypotenuse, so I will go to the 12, and the hypotenuse is 13. 12/13 is my first answer there. Sine is opposite over hypotenuse, so the side opposite angle theta is 5, and the hypotenuse is 13. Tangent is opposite over adjacent, so the side opposite theta is 5, and the adjacent leg is 12, and 5/12 is my tangent. Number 4 wants me to find the measure of the angle. So you can write a trig equation, and you can do it with really any of these. Let's go back to the original. If cosine of theta is equal to 12 over 13, I can't type cosine of theta into my calculator. But what I can do is I can flip-flop the theta and the 12/3. Remember, we have the inverse trig function, which allows you to put in the decimal or fraction to get an angle measure. And so now I can go to my calculator. I can hit second, inverse cosine, and you can type in the decimal, but probably better just do the fraction. And it's going to be about a 22.62 degree angle. They did ask me to go to the nearest hundredths place, so there we go, 2 decimal places. All right. So the next few problems here want me to use special right triangles to find exact values of trig expressions. So I'm going to use a 30, 60, 90 triangle that has a side length of 1, a hypotenuse of 2, and a leg of 1 radical 3, or just radical 3. You can use any 30, 60, 90 triangle, doesn't matter. Sine is opposite over hypotenuse, so I'm going to my 30 degree angle. The side opposite that is 1. The hypotenuse is 2, sine of 30 is 1/2, and you can verify that by sticking that in a calculator. Sine of 60, opposite over hypotenuse. Go to your 60. The opposite side is radical 3, and the hypotenuse is 2, and that should give you the same decimal as your calculator gives you for sine of 60. Cosine of 30, it's going to be adjacent over hypotenuse. You're at the adjacent, or you're at the 30 degree angle. You want the adjacent leg, which is radical 3. You want the hypotenuse, which is 2. So interestingly, same as number 6. Cosine of 60, that's adjacent over hypotenuse. Go to your 60 degree angle. Cosine is, or the adjacent side is 1, and the hypotenuse is 2. So cosine of 60 is 1/2. Sine of 45, you can make any 45, 45, 90 triangle. I like to use legs of 1, and the hypotenuse gets multiplied by radical 2. I'm going to use this 45 degree angle down here, although you can use either one. Sine is opposite over hypotenuse, which is 1 over radical 2. You should rationalize the denominator, though. Multiply the top and the bottom both by radical 2, and we're going to get a little better form answer of radical 2 over 2. All right? Question 10 says, if tangent is 3/4, find the cosine of the angle. Remember what tangent is. Tangent is opposite over adjacent. So this is saying you could make a triangle where at least the ratio between the opposite side and the adjacent side are 3 and 4. And the easiest way to do that would be to just make those sides of a right triangle. So there's angle M, opposite side is 3, adjacent side is 4. You could use the Pythagorean theorem, but most of you probably recognize it's a little 3, 4, 5 triangle. And they want the cosine of angle M, which is adjacent over hypotenuse. So adjacent is 4, and the hypotenuse is 5, and that would be adjacent. Be careful here, they did not ask you to find the measure of angle M. So if you're trying to use an inverse cosine, probably not necessary. All right? Problem solving down here. I'm going to ask you to write a trig equation for each of these. And so you can basically set that up, decide if it's a sine, cosine, or tangent. Using the 47, I have an adjacent and I have a hypotenuse, and that is a cosine. So it's the cosine of 47 is equal to adjacent over hypotenuse. We get something that looks like that. Now, you could go to your calculator and find the cosine of 47 first. The cosine of 47, by the way, is approximately 0.681. And that's telling me that I need to get an x that would make that fraction about 0.681. You can also try to solve first. I can isolate the x by multiplying both sides by 3. X is going to be 3 times the cosine of 47, and 3 times the cosine of 47 is about 2.045. This has to round to the nearest tenth, which is 1 decimal place, so that's going to be about 2.0. Does not round up, okay? Second one here, we have an adjacent side and a hypotenuse. It's another cosine of 37 equals adjacent over hypotenuse. This time the x is in the denominator, okay? We want x equals, that's x over 1. X needs to be on top, so I'm going to multiply both sides by x. That's going to give us x times the cosine of 37 equals 11, okay? Then you want to get x by itself, so you can divide both sides by the cosine of 37, okay? So I'm taking 11 divided by the cosine of 37. Yeah, that's going to be about 13.77, about 13.8 if I'm rounding to the nearest tenths place. All right, the next problem, we have an opposite side and we have an adjacent side. That's a tangent of 32 equals x over 13. X is being divided by 13, so to isolate it, I can multiply by 13. X is going to be 13 times the tangent of 32, which is going to be about 8.1 for x. All right? Next one here, we want to find an angle measure. I have an opposite side and an adjacent side, so it's a tangent relationship. Opposite is 11.9, adjacent is 10. Once again, I can't type tangent of theta in my calculator, but if I use the inverse tangent button, it'll let me type in the 11.9 over 10, and it will give me back the angle measure. So I will try that. Inverse tangent of 11.9 over 10. Going to be about 49.95. They ask us to go to nearest tenths place. It's 1 decimal place that's going to round up. So that'll end up rounding up to about 50.0 if we go to 1 decimal place. Okay, last one of these. We've got an adjacent side and a hypotenuse. So that is a cosine of theta is equal to adjacent over hypotenuse. And same thing, we're trying to find an angle measure. So we'll flip-flop these two values. We use the inverse cosine of 4.4 over 11. And let's see, inverse cosine of 4.4 divided by 11. It's going to be about 66.4 degrees. Oops, a little messy there, but 66.4 degrees. All right, last two questions. I've got somebody flying a kite, 500 feet of string out. The angle made with the string to the ground is 42.5 degrees. Okay, so here's your kite string of 500. It's making a 42.5 degree angle with the ground. You got a kite up here, and we want to know how high it is above the ground. So we're going to call that x. And you got a little right triangle here. If you use this angle measure, I have an opposite and a hypotenuse, which is going to be a sine of 42.5. Is opposite over hypotenuse, x over 500. We can multiply both sides by 500, and 500 times the sine of 42.5 is going to be approximately 337 point, doesn't say what to round to, 337.8 feet. That's what I could round that to. All right, and your final question. We've got this helicopter flying 150 feet above the ground. So there's my 150. There's an angle of depression that's 18 degrees to the fire. Remember that you want to draw your horizontal sight line first of all. They would be looking out this way, but they're rotating down 18 degrees to see this fire over here that's burning, okay? So it's this upper angle that's 18, not this angle here. Or if you want to subtract 18 from 90, this would be a 72 degree angle over here. Anyway, you should be able to make a right triangle. And be careful, if they ask how far is the helicopter from the fire, they want this side. If they ask, horizontally on the ground, how far is it? That would be this side here. And this time they say how far would have to travel horizontally. So we're basically saying this distance here, which would match up with that distance on the ground. Remember that because of congruent alternate interior angles, the angle of elevation from the fire to the helicopter is the same as the angle of depression down to the fire. So I'm going to use this lower triangle here. You have an opposite side and an adjacent. It's a tangent of 18 is equal to 150 over x. We have x in the denominator, so we need to multiply both sides by x and cancel. X is being multiplied by the tangent of 18, so you can divide by the tangent of 18 on both sides, and x is going to end up being whatever 150 divided by the tangent of 18 is. So 150 divided by the tangent of 18, which should be a pretty big number, yeah, about 461.7. Does it say how? Doesn't say what to round to. So 461.7, and I think this is in feet, and that's our final answer.